The final push is on. Okay? All right? We are starting, we got 3 topics that we've got to get done yet this year before we can give you this. And we have to give you this. Okay? So we have to give you parametric equations. We're going to start that today. It's going to be a fast unit. It's going to be a 2-part test. Okay? The first part of the test is going to be next week, Thursday, a week from tomorrow. Okay? It's going to be the first part of the test. The second part is going to be on Tuesday the 25th with the greatest day in pre-calculus. Okay? Okay? So that's the second part of this test is on the 25th. And I'm gonna let you sit in anticipation for the greatest day of pre-calculus on the 25th. Okay? Then after that, we've got to start polar coordinates. Then after that, we've got to do complex numbers, and then all that getting ready for taking the NTC final exam, which we have to get done by the 19th of May. So we're already almost halfway through April, so we've got to accelerate a little bit. Yesterday was your vectors and nav test. If you didn't complete it because we had the assembly in the afternoon or you weren't here, the sooner you get that done, the sooner that you're caught up, that means you can go on. We're going to keep putting information in your brain, okay? And that's going to keep pushing down that other stuff. So get tested on that other stuff before it gets buried underneath the mountain of all this new information coming on. So get it your butt in the MRC soon and get that done if you haven't done so already. Okay? So this is a picture. This is not, we're still not on your note sheet yet, but the next slide will put us on your note sheet. This is a picture of a parametric equation. Now you may be saying to yourself, it looks like we gave a pen to a baby and they just wrote on a wall. Okay? But it's math art. It's smart. Okay? Alright? Math art. It's a beautiful parametric equation that we will be able to graph here. You'll be able to graph this within the next half hour. We won't get to it, but we'll do more of this kind of stuff tomorrow. Okay? So here is this parametric function of that graph. Okay? So let's talk a little bit about what a parametric equation is. We are now on your note sheet that we are going to be going along with for you. Okay? So, way back in middle school, okay, maybe even the upper reaches of 5th grade-ish, maybe I don't really know. You started graphing functions. You started plotting points on a Cartesian coordinate system. Okay? And you would plot the point x comma y, but your function, so your how you would plot that point, you would be given some kind of a relation. Y equals mx plus b, or y equals 3x squared plus 7x minus 4. And you would plot those points. Okay? Well, when you were doing that, and you were experts at that now, you would be taking some kind of an input, your independent variable, if you will, your domain, if you will, all 3 different ways, okay, that we can say the x value in all of those. Inputs, independent variables, domains, all that fun stuff. And what you do with that is you would plug that in to your relation, your f of x, whatever your equation was. You plug that in. And you do that now. Sounds familiar? You've done it 10,000 times over the course of your academic career. Okay? Right? So you guys, again, are experts at it. Then, once you plug that into your function, you got out a y value. That would be your output. Your dependent variable, if you will. your range, if you will. Okay? And from that, you were then able to plot the point x comma y. And you'd repeat that process over and over and over, and that would give you a smooth curve if it were a curved function. Algebra 2 Extended today is taking their test on rational functions. You've graphed rational functions, you've graphed parabolas, you've graphed lines, you've graphed all cubics, quartics, all that fun stuff. You've graphed them all. Okay? Right? And so you would plot that point, and you would be great, grand, and wonderful. Okay? Well, now we're going to take that and we're going to add something to it. And that adding to it is going to turn it on its head. Because now in parametrics, we're graphing with 3 variables. But we're not graphing in 3 dimensions. We're graphing with 3 variables. And how this works is now instead of you picking an x to put into your function is going to have 2 functions. A function that decides what x is, and another function that decides what y is. And both of those functions are going to be of the variable t. They're going to be defined by the variable t. So you might have something like t squared minus 9. And you might have 2t plus 1 if you're looking over at actually right below that. If you look right below that, that's those functions right down there. Okay? So you might have those functions as your definitions of what x is and what y is. So then, now, t becomes your input, your independent variable. X and y, both of them now are your output. So what you're going to do now is, now you're going to plug t into x and y, and then now you plot the point x comma y. So you've got to plug your point into both x and y, or you got to plug, I shouldn't say plug your point, plug your t value into x, plug your t value into y. That gives you your output of x comma y that you can then plot on your Cartesian coordinate system. Okay? Let's do this. Now, the very first thing that we'll wait on that one because we'll get to that when we get to the calculator. We're going to do 3 things on this one problem. The first thing is we are going to graph it by hand. Okay? Then the second thing that we're going to do is we're going to graph it on the graphing calculator. Then the third thing that we're going to do is we're going to change our parametric function into a regular Cartesian function like we would normally have. Okay? All right? So here is what our x is defined as t squared minus 9. our y is defined as 2t plus 1. Okay? Now, you'll notice in a parametric function, you are also given this third line. And that third line is extremely important because that is your range of t values. In a regular function, we would always put arrowheads on the ends of it. Your sine and cosine graphs that you graphed way back before, we put arrowheads on those. Your lines, if it was y equals mx plus b, you put an arrowhead, signifying that it continued on and on and on forever following that same pattern. In parametric functions, you don't. They stop because we restrict the t values. T is not just anything. Okay? T is within a specific range. So your functions have endpoints, or your relations, your parametric equations have endpoints. They don't continue on forever. Next week, Thursday, when you're graphing on your test, if you put arrowheads on it, we will mark it wrong. Okay? Because it doesn't continue on forever. It stops. And we'll see that here. Okay? So what we're going to do is we're going to make ourselves a rather large t-chart. Now, in that t-chart, we have to start at -3. We have to end at +2. So let's go with just the integers in between there. If you wanted, you could do any number in that range, but your t values all have to be within that specific purple box range. I can't plug in t equals 10 and get an answer in this function. Doesn't work, not within my range. Okay? Then, now, in the past, when you made a t-chart, you've just plugged those values into your function and gotten out one value. Now, you've got to plug it into two functions. So your first function that you're plugging it into is t squared minus 9, because that's what x is equal to. Well, here's t, -3. What is -3 squared? Minus 9. 0. So my x value here is 0. What's -2 squared? Minus 9. -5. -1 squared. Minus 9. -8. 0 squared. 0 minus 9. -9. 1 squared. 1 squared. Minus 9. -8. 2 squared. Minus 9. Love it. Now we're getting better. Okay? Then we go over to the y's. And the y's were 2t plus 1. 2 times t. Or excuse me. 2 times -3. -6 plus 1. -5. 2 times -2. Plus 1. 2 times -1. Plus 1. 2 times 0. Plus 1. 2 times 1. Plus 1. 2 times 2. Plus 1. Okay? So there you've done all your math. Now you're going to go and you're going to plot the points. The point you're going to plot here is 0, -5. That is 2, 4, and 5. It is right there. Then you're going to plot the point -5, -3. 2, 4, 5, 1, 2, and 3. It's right there. Then you're going to plot the point -8, -1. 1, 2, 3, -1. Then you're going to plot the point -9, +1. That's right there. Then you're going to plot the point -8, comma 3. That's right there. Then you're going to plot the point -5, comma 5. That's right there. Okay? Now, in the past, here's what I was talking about. Okay? In the past, what you've done now is you've always done this. Right? The problem is, now in parametrics, it stops there. So that part can't be there. It stops there. So that part can't be there. That is just my graph right there. That's it. No more. Doesn't continue on forever because I've stopped. I've gotten to the ends of my T range. Okay? Let's plot this on a graphing calculator now. What I'm going to need you to do is I'm going to need you to turn your graphing calculator on. You're going to actually double tap the on key. And what that's going to do is it should bring you to a screen that looks similar to this. It might look a little different because yours might actually say new documents and all that stuff. You're going to hit number 1, and then you're going to say, no, I don't want to save it. 1, no. Then that should take you to a screen that looks like this. Yes? Okay? So now we are going to want to graph. So we're going to have to go into number 2. You can either punch the 2 key, or you can scroll down to it, or you can slide your finger across the bar to the number 2 and then hit enter. That brings you to a graph that looks like this. Now this, the default graph for the TIs, is a regular rectangular graph. Okay? We're graphing in parametrics, so we need to change this to a parametric graph. We do that by going Menu, Graph, Entry, Edit, number 3. Again, you can push number 3, you can scroll down, or you can slide over. And then we want to pick parametric, number 4. Now, when you click on that, if you'll notice, your graph, the part where you enter the equations, has now changed. Now we've got an x function, a y function, a t range, and a t step. Okay? So for our x function, we're going to define that as t squared minus 9. Then down 1, or you could hit tab, and we're going to define our y as 2t plus 1. Everybody with me so far? Okay? Now, this next part right here, where it says on yours, it goes 0 is less than or equal to t is less than or equal to 6.28. What that is the default, because parametrics are normally used with trig functions. That goes from 0 to 2 pi, first lap unit circle. Okay? That's what that is. Okay? So we need to change that because this function is not first lap unit circle. This function goes from -3, so I'm going to go down to there, and I'm going to delete the 0, -3. Now, when you're typing, just so you know, this key is the negative key, this key is the subtraction key. They are different. You can't say subtract -3 there. Your calculator will yell at you when you hit enter. Okay? We want to go all the way up to 2. So we go -3 to 2. That part right there limits my t value. The t step part, the next one, that is how often the calculator is going to calculate values and plot those points. The bigger the t-step, the chunkier your graph looks. Okay? The smaller the t-step, the smoother your graph looks in all cases. Okay? All right? So then when you hit enter, you should see now then the same graph that we just had. If I switch back and forth between them, they look almost identical. The scaling is a little off, but they look identical. Okay? Good times. Okay? Then now the second part of this is we need to eliminate our parameter. So how we do that is, well, we start again with our parametric equations. We had x equals t squared minus 9, and we had y equals 2t plus 1. First thing that I'm going to do is I'm going to solve x or y for t. And I solved one of them for t. Pick the easy one. Which one's the easy one to solve for t? Y is the easy one to solve for t. If I solve this for t, I would first subtract 1. Then I would divide by 2. Then, oops, I shouldn't say plug. Plug we'll say it this way. Substitute. So I'm going to replace t in my other one with y minus 1 all over 2. Okay. So then this would become x equals y minus 1 quantity squared all over 4, still minus 9. I could add 9 to both sides. And I could multiply both sides by 4. Oops, got the brakes. Almost hit the bad button. The erase everything button. Which, if you were an Algebra 3 student right now, they would tell you that's a that is a right opening parabola because the y is squared, the x is not, and the coefficient on the non-squared variable is positive. So it's a right opening parabola. We just took a section of it in our graph. Okay? Good times. Okay? What I would like you to do now is I would like you to, 1, make the table that go along with this one, with example number 2. Graph it, eliminate the parameter, and check it all on your calculator, please. Do so now. So in your table, you should have gotten, when I go t plus 1, negative 2 plus 1 is negative 1, negative 1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 2 is 3, 3 plus 1 is 4. Negative 2 squared is 4 plus 2 times negative 2 is negative 4, so then that should be 0. Negative 1 squared is 1, minus 2 is negative 1. 0 plus 0 is 0. 1 plus 2 is 3. 4 plus 4 is 8. 9 plus 6 is 15. So now I got to go over and I got to plot those points. Negative 1 comma 0 be right there. 0 comma negative 1 be right there. 0 comma 0, oops, that breaks. 1 comma 0, sorry, I was looking, getting my eyes crossed on lines. 2 comma 3, 1, 2, and 3 is there. 3 comma 8, 4, 5, 6, 7, 8 be there. 4 comma 15, 9, 10, 11, 12, 13, 14, and 15. Right there, no arrowheads. Yes? Good on all accounts? Okay, I'm going to skip to part D. Part D says verify it on the calculator. There it is, looks the same. Okay, all right, good there. So now let's eliminate the t. So my x was t plus 1. So I would call that x minus 1 equals t. My y was t squared plus 2t. So then that's going to be y equals x minus 1 quantity squared plus 2 times the quantity x minus 1. If I multiply out x minus 1 quantity squared, I get x squared minus 2x plus 1, not just x squared minus 1, or x squared plus 1. Okay? Don't just square and square. Remember, got to multiply it out. Distribute here, I get 2x minus 2. All told, if I could simplify those, I get y equals x squared minus 1. And that would be me eliminating the parameter. Okay? Good? Whew! Tomorrow, we'll do some more graphing work on the calculator, and then we'll get into launching things at an angle. Okay?